Winter arrived without warning systems. No forecasts, no weather apps, no alerts telling you to stock up before the storm. For roughly 300,000 years, every human ancestor on the planet faced the same problem when temperatures dropped and the days shortened to almost nothing. The food disappeared. The warmth disappeared. The light disappeared. And they had to survive anyway. The common assumption is that ancient winters were simply brutal endurance tests, months of huddling in caves waiting to die or not die. But that assumption is almost entirely wrong. Start with the problem of calories. Winter, more than any other season, was a biological emergency. In northern latitudes, a hunter-gatherer group of 25 people needed somewhere between 2,000 and 3,500 calories per person per day just to maintain body temperature in sustained cold. That's not including the energy cost of hunting, or moving camp, or keeping fires alive through snowstorms. Archaeologists excavating Ice Age sites across southern France and Central Europe have found evidence of deliberate fat storage going back at least 30,000 years, not meat. Fat, specifically. Because fat contains roughly twice the caloric density of protein, and the body metabolizes it far more efficiently in cold conditions. The ancient humans who made it to spring were the ones who understood this distinction, even without the vocabulary to name it. But the calories were only part of it. Here's what's fascinating. The actual daily rhythm of winter life was nothing like what we tend to picture. In 2018, anthropologist Kara Okebok at the University of Notre Dame published research on cold weather metabolic adaptation in Arctic hunter-gatherer populations. She found something that directly contradicted decades of assumptions about ancient winter activity. The people who survived the coldest winters most consistently were not the ones who moved more. They were the ones who moved less. Deliberately, strategically. Okebok's term for it was thermogenic inactivity, a controlled reduction in unnecessary physical output, designed to preserve caloric reserves during periods when food acquisition was least reliable. This wasn't laziness. It was biology applied with precision. When temperatures drop below a certain threshold, every movement costs more than it would in summer. A 2-hour walk that burns 400 calories in August might burn 700 in January. Ancient humans appear to have understood this at the population level, even without the vocabulary to explain it. The archaeological record from Upper Paleolithic sites in the Dordogne Valley shows dramatic reductions in the range of toolstone sources during winter months. In summer, groups ranged 80 to 120 kilometers from their base camps to acquire specific materials. In winter, that range collapsed to under 20 kilometers. They stayed close. They stayed still. And while they stayed still, they worked. This is the part almost nobody discusses. The surviving assemblages from winter occupation layers at sites like Lascaux are not just paintings. They are workshops, bone needles, engraved antler rods, thousands of small blades struck from cores showing evidence of extended patient pressure flaking, the kind of detailed work that requires sitting in one place for hours with adequate light and warmth. Archaeologist Olga Sofer spent years analyzing impressions left in fired clay fragments from Dolní Věstonice in the Czech Republic, dated to roughly 26,000 years ago. Those impressions showed woven plant fiber, baskets, nets, possibly textiles. None of those things preserve easily. But the impressions survived, and what they tell you is that winter was the season when people made things. There was also something happening at the social level that winter forced into existence. In summer, hunter-gatherer bands typically split into smaller foraging units of 4 to 8 people, spreading across the landscape to cover more ground and follow more game. Winter reversed that pattern entirely. Resources concentrated, and so did people. Ethnographic data from modern Inuit and subarctic Diné groups consistently shows that winter was the season of aggregation, when dozens of family units who had spent months apart came back together. The population density inside a winter camp could be 5 to 10 times higher than a typical summer foraging group. That crowding produced friction. It also produced culture. The storytelling that happened in winter camps wasn't casual. It was institutional. Among groups studied in the 20th century by ethnographers like Robin McGrath and Anne Feenup Riordan, winter was the designated season for transmitting the oral archive. The stories told around winter fires weren't entertainment. They were law. They were history. They were technical manuals disguised as myth, carrying information about where water could be found in drought, which plants treated infection, how to read weather and cloud formations. Some of these story cycles required multiple evenings to complete. You couldn't tell them in summer. The group was scattered and the days were too full. Winter gathered everyone into the same space and held them there long enough for the entire archive to be passed down intact. Winter also changed how people slept, and not in the way most assume. The assumption has always been that ancient humans simply slept more in winter because there was less daylight and less to do. But the physiological evidence is more complicated. Researcher Ganesa Bagwath at the University of Munich analyzed cortisol and melatonin rhythms in populations with minimal artificial light exposure across multiple seasons. He found that in deep winter, the period between first and second sleep, that quiet, wakeful window documented by historian Roger E. Kirch across hundreds of medieval records, extended significantly. Not by minutes, by hours. Winter nights gave that reflective middle period room to breathe. People were awake in the dark for longer stretches, in a hormonal state closer to meditation than ordinary wakefulness, in the middle of the coldest nights of the year. What they did with those hours left traces. The painted chambers at Chauvet Cave in southern France, dated to roughly 36,000 years ago, show evidence of being created across multiple separate visits during winter months, based on sediment layers beneath the footprints preserved in the cave floor. The artists weren't working in the bright activity of summer. They were painting in the deep dark of winter nights by firelight, in the quiet hours when the camp outside had gone still. The images aren't random either. They show animals in motion, overlapping, charging, rotating, as firelight moved across the curved rock surface. The cave was designed to be experienced by fire. It was made for winter, for the long dark. For those hours between first sleep and second sleep when the mind was calm and the world outside was frozen and there was nothing left to do but reach into the wall of a cave and pull something permanent out of it.